Let us discuss another method for add. Previously in linked list, we just only take a value to add into the linked list. This time we'll take two values, the element we want to add and the position. Let us start with the case when we want to add at position 0. What you see right now in the right hand side is the graphical representation of the linked list. Notice here we have first and last pointing to the respective nodes. This box that you see in the left corresponds to the method call. Here we invoking add with two parameters, 0 representing the index and the string C representing the string element we would like to add. The first thing is to go check the method call. Obviously, we're passing two parameters. That's why we're going to enter into this method. The very first thing we have to do is to check the boundaries. Here what we want to do is to make sure the proper bounds are satisfied or checked before we potentially get an exception. Here we only checking if the position is smaller than 0 or it happens to be larger than the current size. In both situations, these are not satisfied because position 0 is not less than 0 and 0 is not greater than 5. Therefore, we're okay. We don't have to check this validation. Therefore, we're going to run into the next condition, checking if position is 0. Here we anticipate that we're going to enter the value. We're going to insert the value at position 0. Therefore, the first node has to be modified a little bit. Before we modify first, we have to create a new instance of the node. Here we're going to use the very first constructor, if you remember, where we're going to pass the value as a first parameter and then the connection to the .next. The connection to the .next will be the first because here the node that we're just creating .next will point to the first value that we have. We do this in order to avoid the elimination of the rest of the list. Once we create this connection, we're going to have this representation. The next thing we have to do is to assign it to the first, which is the left side of the equal sign. Here we're going to point the first to that value. Now we satisfy this line that is being highlighted. The next if statement only checks in case the last element is the null. It means that before we add in this element C, the list was empty. That's why list was pointing to the null. Fortunately, that was not the case, and we can just skip. Return semicolon means return the void. This is a typical value that we're going to keep doing in order to represent return the void. Notice that this method is a void method. Therefore, this will allow us to exit immediately and exit the method. Now we have one more element into the entire list. What happens if we add somewhere in the middle of the list? In this case, suppose we want to add at position 4 the value C. Again, we're going to invoke this method and we check for the boundaries. We already talked about this, therefore we're going to skip this condition. The second case is in case we're adding at position 0, which is not the case, so we're going to skip. The third condition is when we're going to add in the middle. Here we need to use a temporary variable, often called as the predecessor. This value will help us to point to the first value. We're going to move forward just to find the position right before we're going to add the element C. This is often called predecessor. This loop, which we already know, which is not at position 0, we're going to start at position 1. This is only to keep track just before the element we want to add. The condition checks is as long as this value is smaller than or equal to the current value that we want to add, minus 1. We're going to trace this, and the only way we're going to move forward is by p.next. Since that is true, we're going to move forward our pointer p by 1. Then we increment our value k by 1. Then we check again. Is 2 less than our value index, which is 4 minus 1 is 3? Is 2 less than or equal to 3? That is true. So we move forward by p.next. We increment our predecessor pointer, checking now is 3. Now we check, is 3 less than or equal to 3, which is true. So we're going to move forward one more value. After that, we increment k by 1. Now is 4. Check this out. By the time we check again, is 4 less than or equal to 3, that is not true. Now I want you to pay attention. We already set p right before position 4. Remember that we want to add the value c at position 4. So the purpose of line 15, 16, 17, and 18 is to locate ourselves right before our value that we want to insert. This is in order to avoid a disconnection of the rest of the list. The next step is to reroute the position. Notice what's going to happen. We're going to create a node using the first constructor. Here, we're going to provide the value here, C. And p.next will be the .next. Notice that p is pointing to the node that is at position 3. .next, it will be the node at position 4. So the constructor will point the value .next to the node. Here we just established that connection. The remaining thing is to connect the previous one, which is the predecessor .next. So p.next will point now to the node that we just created. This arrow that you can see here will be rerouted. Once we establish that connection, we have no problem. Now we can connect easily the value at position 4. The remaining thing is in case p.next is equal to the null. That means that in case we add it at the very end, we have to update our last. In this case, didn't happen. Therefore, we can skip this part. I want you to pay attention because in case we don't do that reroute, we can lose the rest of the list. For example, this way. That is why it's very important to have the list connected through p.next and therefore use a predecessor.